thank you so much. I hope it's okay if I take out the gown mask, so it's me. I didn't send my brother. Well, thank you so much for this introduction for you, for being so numerous today. It's a sunny day outside, so you know, we can't take these things for granted. Yeah, so the gifts, the Christmas gifts, so they know all those. Okay, so today I'm trying to present to you an idea for which I'm going to present today already for the first time, I thought. So it's a friendly audience, you heard the introduction, this is the right time to come out with something new and get really some feedback from you, which I really hope to have during the discussion at the end. So you heard that one of my major projects is connected, it's called the Sphere, because it is connected to the analysis of the edition history of one very famous treatise in the history of medieval and then modern science, which is the Tractatus de Sfera of Ioannis Sacrobosco. This is a huge project, there are about 20 people involved, and it's a project in computational history. I will not speak about this project today. This treatise was compiled and used in the frame of the then emerging universities in the 13th century in Europe. And obviously, while working on this project, I always ask myself how to contextualize even the entire project. So what is the real context, the real historical context? Which obviously is the quadrivium, as we know, because the quadrivium is the way that the early universities, until the end of the early modern period, used to organize the mathematical discipline. So it's an organizational scheme for scientific knowledge. So trivium and quadrivium. So you have heard, I'm sure all of you have heard these words and know at least something about this concept. So the Tractatus is part of this. It's part of this because it was a book mostly used over the centuries to teach astronomy, which is one of the four disciplines. So, and I start from the quadrivium in this period. And I go to emergence of modern science, which means for me, let's say roughly the early modern period, roughly the 16th up to the half of the 17th century. We know that these time scales are somehow a little bit difficult because different regions in Europe have been experiencing different time speeds, so to speak, in the development of the sciences and the entire material and financial and institutional infrastructure needed for the development of sciences. But let's say, accept this please, let's say half of the 17th century at the very latest. And I don't specify now which countries we are speaking about. So what I would like to discuss with you today is basically a thesis that can be reduced to very few words. And that the modern science, so when we are in the 16th and 17th century, can be seen as the result of a process of disintegration. So instead of speaking about revolution, now we speak about disintegration. Maybe I'm reflecting a certain pessimism of our society, I don't know. I will leave this judgment for the next generation. But when I speak about disintegration, I'm really speaking about disintegration of quadrivium and the meaning of its meaning. So, but this will come at the end. So first of all, the quadrivium. Quadrivium is a concept that has very, very ancient origins. I will not discuss about them, just to show to you that I know that it is older than the medieval period. And my focus, as I said, is about the 12th and the 13th century. So it's the moment where medievalists, generalist historians say that it is the first European revolution. It's the first moment where we can speak about Europe, the emergence of an identity for a series of reasons, urbanization, the beginning of local markets, and then the beginning of a trans-regional market in the Mediterranean, the estabelecimento, which is another word for urbanization of this period, and obviously, very important for us, historians of science, is the emergence of this new institution, the university, which still exists as we are here now. So this is my starting point. And when we speak about the quadrivium, we and we take into consideration the late medieval period, then we take into consideration a certain amount of historical sources. And when actually the 12th and 13th century vision or perception or realization, even in the curricula of the universities of the quadrivium, was very much associated with late ancient works. Not the very ancient works, but the late ancient ones, and especially with those of Boethius. Boethius, the Instituzione Aritmetica, the Instituzione Musica, Boethius systematized all these disciplines, and the quadrivium is indeed so transferred to the university is constituted by these 4 disciplines, mathematical disciplines, all of them: arithmetic, music, geometry, and astronomy. This is not just a list because I decided to list them, but this expresses a logical order as in the view of Boethius and in the view of the late medieval commentators. So one is necessary as a condition for the next. Arithmetic for music, music for geometry, and all of them, music and arithmetic for geometry, and then geometry, music, and arithmetic for astronomy. So there is a logical order, which in other words means that they are interconnected to each other. There are interdependencies among these disciplines and among the knowledge fields or knowledge domains that these disciplines, these names represent. So this interconnection is there because the quadrivium is not just an organizational scheme for knowledge. It's not like just saying humanities and natural sciences or mathematical sciences. It's not creating dichotomies or more than dichotomies. The quadrivium is there because it has a meaning, it has a goal, and this has been, I think, best described by Anne Moyer in a beautiful paper on the Boethian works of the quadrivium, where she pointed to the fact that the quadrivium altogether is there in order to show and display, to understand the harmony and the order of the cosmos, and through this perception of the harmony and the order of the cosmos, then there is a connection between the knowing human being and God, the creator of the cosmos. So this is, we are in the late ancient period, and then this is the medieval interpretation. So then you see already that I start putting some doubts into all this, so there is an end, a question mark here, and we will come to the end, to this end, or toward the end. So what I will do from now on is a sort of description of each of these disciplines and what was happening in the frame of the study of the knowledge of this discipline, not only in the late medieval period, but giving also some hints about the early modern period or the centuries in between, 14th and 15th century. So it's basically the empirical part of the lecture, and this will be the biggest part of the lecture. And so also be descriptive if you want. So have to be, as the subject is gigantic and I'm covering 3 centuries, basically I have to be in a sense also a little bit superficial. And I hope you will nevertheless find it interesting. So let's start from the first one. So arithmetic. Arithmetic is the basic. Arithmetic means in the arithmetic of Boethius, which is the book the students were using in the class. As you know, in the statutes of the time, there was not the teaching the class of arithmetic, but the class was identified with the book read by the students. So it was the class on Boethius, the arithmetic. So the arithmetics in that sense was basically theory of numbers, what we would call now theory of numbers. It also on a very philosophical level, something that we usually don't even do now is to study mathematics. There's only some of them, depending also on the commentators or on the teachers. And then the second book, it moves over toward the fundamentals of theory of proportions, what we call now theory of proportions. So on a very general level. In order to understand what theory of proportions are first, and then to give a general rule, very general, very abstract rules about theory of proportions among numbers. So numbers is the basic to understand everything. So in the words of Boethius, I wrote it here, so the last sentence, number was the principal exemplar in the mind of the creator. So this is a sentence from book 1 width. So this is the stuff. So as you see, it's in its original form, late ancient, Neoplatonic, Platonic, Neoplatonic, towards a sort of toward Areopagita. So there is, you see, the all early medieval ideas behind this, and you can imagine how in the 13th century which role this, which impact this kind of knowledge had. However, already from the very beginning, arithmetic is also much more, and the quadrivium is much more. The quadrivium is invasive, it's everywhere, it's in the culture, in the literature, in the art, and it is, for instance, also in the practice of designing, for instance, cathedrals, Romanesque and Gothic cathedrals. So the biggest sign of the clergy and the clerics in the making of Europe in the 12th and 13th century are those cathedrals. And many of them are designed following the rules that are one to be found in the arithmetical collections, in their display. But then arithmetic in the 13th century university is also much more than this. There is also another book that was used for the class in arithmetic, and this book was called Algorithms. So you see here there is something else that Boethius didn't have, the reception of Islamic science. Algorithms is a work used in order to introduce the Indo-Arabic numerals, numeral system, and all the operations, all those that we studied as well in the basic school ourselves. And then there is also a very important subject in algorithms that was totally absent in Boethius, but was very important in the 13th century, and it was the subject in order to teach the students how to translate basically from the decimal to the hexadecimal system. Decimal system used in arithmetic, in geometry, for instance, but not in astronomy, where it was used the hexadecimal system. So this is a fundamental operative knowledge in order to deal with the math behind all these great ideas of the harmony and order of the cosmos. Then we obviously have also something else, something that goes even outside of the universities, and it is the so-called practical arithmetic or the merchant's arithmetic. We start more or less in the same period, maybe a little bit later, with the Liber Abaci of Fibonacci and everything that followed this book. So the creation of new schools, of new institutions, a new class, social class, we would say, we could also say a new math. A math that used, in parts, overlap with the algorithm, doesn't have anything to do anymore with the theory of numbers, and doesn't the question of theory of proportions in the way the arithmetic of Boethius does, but out of which there is also the emergence of other treatises called logistics, taking back the ancient Greek, idea of logistics as a teaching of math. And this logistic is basically a sort of algorithms turned down in the approach, upside down in the approach, is a problem-solving approach, and the logistic as such also entered the university there. So the whole abacus and merchant mathematics had actually reflexed back to the university as well. So as you have seen until now, my way of arguing until now is to show to you that when we speak about the quadrivium in the late medieval period, we are already speaking about something that is actually different from what Boethius conceived as the quadrivium, despite of the fact that Boethius and the concept of Boethius was the underlying concept in order to create the curricula in the university. The university accepted this view, but as a matter of fact, there was much more. And this much more seems to go in most of the cases, not in all of them, but in most of the cases, toward a precise direction, which is more the practical direction. Merchants, architecture, algorithms, etc. So now we move to the next discipline, which is music. Music is basically, in the term, in its original form, it's the collection of specific theories, specific proportions. So you read first the arithmetic, the general theory of proportions among numbers, and then you go into music. So the one is propedeutic to the next, because then in music you learn the ratios and the numerical proportions that, however, are already now associated to something else that is not present in the arithmetic. And this something else is musical harmony, and the musical harmony expressed by the intervals of the Pythagorean monochord. So there is a connection to something which is real, something that you can eventually listen to. And I don't know if you ever had the chance to read one of those treatises of musical harmony, we would call now, of this period. They are terribly difficult from a mathematical point of view. It's very hard to enter into this subject, and this was the main goal of the Istituzione Musica of Boethius, was to introduce the students, or to introduce this knowledge into this specific group of proportions and how to deal with them. So you see here on the right side, for instance, that this was still subject taught at the beginning of the 16th century in Leipzig by Konrad Foppler, for instance, a quadrivial teacher. However, this was slowly an exception in this time. So this part, some aspects of the music of Boethius actually disappeared quite soon, already in the 13th century. So the music of Boethius is divided into three big fields: musica instrumentalis, musica humana, and musica mundana. Musica instrumentalis, the words say by themselves, it's the music related to what you can listen when you play an instrument, for instance. And obviously here we also have rules, and it's very limited to the, in the case of Boethius, to the intervals of the monochord. Then the singing is a little bit unclear. The medieval commentators were sometimes tending to say, okay, it belongs to the instrumentalis because we listen to it, or maybe it belongs to musica humana because it's the humans singing. And the goal of the musica humana was to, it's actually the most difficult to grasp, was to bring together or to unify soul and body while perceiving the creations and to these unifications of soul and body of each human being, to bring them to the Creator, to God. So that's why singing was sometimes associated rather with musica humana, because this was reflecting the increasingly relevant practice of the 12th and 13th century to sing together in the churches. And this is the moment of an important turn in music. We have the emergence of polyphonic musics and polyphonic choirs, and so all singing together was a very relevant aspect, especially at the universities. So in order to create the group and find God in this unification of body and souls. So that's why there is a little bit of doubts among the commentators whether the singing belongs to the one or to the next. Then the musica mundana is one of the greatest goals of the period. Musica mundana expresses the mathematical, or wanted to express, let's say, all the mathematical aspects needed in order to bring to a convergence the theory of proportions, the musical theory of proportions, so the intervals of the Pythagorean monochords, with the composition and the movements of the cosmos, of the machina mundi. So basically, the intervals, the proportions, the ratios among numbers had to be found among the distances, for instance, between the astral bodies. So the distances between the Earth and the Moon, the Earth and the Sun, and all the other planets would give the ratios that you then could find in the Pythagorean monochord and express mathematically through the music, the proportion, the musical proportions. And the speeds of the planets would give you the peak. And peak and proportions then create what was called the universal harmony. So everything is in harmony, and this harmony is expressed on a mathematical level, bringing together mathematical astronomy and musical astronomy. So this is one of the greatest goals of the period. But this had already a problem at the very beginning of the university. So there was musica mundana, there was the teaching, but at the same time, in the 12th century, there was the great reception of Aristotle's on the heavens, the cello. We have Gerard of Cremona and William von Morbecke's translation. And Aristotle actually has very sharp criticisms against this idea of the universal harmony. And one of them is very Aristotelian. To create a sound, you need a percussion, you need a clash between two bodies. So which clash can happen in the superlunar Aristotelian world? The bodies move, in this ethereal, we would say world, but ethereal, whether there is an ether or not is also another question. So for sure there is no friction in the cello's ideas of Aristotle. And not also in the Averroes commentary that was also translated. And also not in Simplicius' commentary that was also translated. So the criticism was very strong, because the theory of sound of Aristotle was very convincing, or sounded very convincing. And the other idea, which is also, I think, in a way, it reminds me very much to Aristotle every time I think of it, it just said, and even if we accept that there is such a universal harmony, such a sound of the planets traveling, but given the size of all the cosmos and the huge speeds of everywhere, then this sound would be so strong that it would actually destroy the entire cosmos. So that is a beautiful criticism and had a beautiful, strong impact in the 30th century in the universities. So that the musica mundana remained there. It had to be taught, but it remained as a sort of parallel niche that was kind of tolerated. And in comparison to this, actually the practical turn of music, especially the singing, acquired in relevance much more from the very beginning of the universities because of this criticism. So I took a little bit of time to follow this idea of the musica mundana. So did somebody actually work on this? So you can find somebody working on it. You can find it mentioned several times, and as far as I know, I found only one anonymous medieval commentator who really tried to make the math. We don't have, unfortunately, the Astronomia of Boethius. We do have the Musica, but we don't find any math there, and we don't find it anywhere. So I had a look, for instance, in the early modern period at the works that actually at least speak about the musica mundana. There are 27, the printed works, so in order to, not the manuscripts, only the printed works, there are 27. Now, if I look at the Tractatus de Sfera of Sacrobosco and similar treatises, I found for the same period, he only printed 359 different editions. So here are only 27. And most of them, they are just the opera omnia of Boethius, so which does not really testify for an interest in musica mundana, but just because it's the great Boethius that made a lot of different things. And then we have Johannes de Muris, the only, together with Jacques Lefebvre de Table, the only two commentators that also tried to enter a little bit more into the subject matter of the musica mundana, but at the same time were great authors toward the practical turn of music, already in the 13th century, Johannes de Muris, and in the 50s, Jacques Lefebvre de Table. And then we have the Furio and Valeriani, so experts of music, they speak about this. They mention this idea, but they mention it like one paragraph in the entire works. And they don't say how to do it. The idea is great in a sense, but from a mathematical point of view, it is not so easy also because the distances are not known, but even if you know the distances among all the planets, all the speeds perfectly, how to really bring it together with the Pythagorean monochord is not so easy to think about this. So I also had a look, the distribution of production of these books. If you take the one in the middle, the pie in the middle, so it's divided until 1530. You see that these books are not many, but they are kind of produced all over Europe, or they are spread very well. If you move after the 1530, you see that most of the books are actually produced only in one city and actually by one printer, and it is in Basel. So it means this sort of knowledge has become a niche in the market, people would say now. It's no more really demanded. It's not certainly not used at university on on a regular level anymore. Otherwise, you would find it reduced for the students in the second half of the 16th century. And it is not anymore. So we have the consequences, at least in my opinion, this is due to the consequences of Aristotelian criticism, is that we have already in the medieval period, in the late medieval period, a practical turn in music. So we don't have any more music really in the sense conceived by Boethius. We have increasingly more attention for the tuning of the instruments, and out of this work for the tuning of the instruments, we know that we have an emergence of a new musical theory, a new musical harmony. So great names, Zarlino, Vincenzo Galilei. And so but it's something that is completely different. It's related to the praxis itself. It's not the Pythagorean monochord, or the idea of a Pythagorean monochord. At the same time, the idea of universal harmony seems to survive. Think of Kepler, Mersenne, l'harmonie universelle. So the universal harmony is, let's say, devoided a little bit from its direct mathematical meaning that it is in Boethius, or in the original form of the quadrivium a la Boethius, but still remains as a hermeneutical idea, also mathematical idea if you look at Mersenne, but it survives the cosmological worldviews. So from Pythagoras, Plato, Eudoxus, we always have the harmony, the universal harmony. And then we have the 30th century, the Aristotelian Ptolemaic system, or let's say the Aristotelian system as received in the medieval period. And then we have Kepler, and then we have Mersenne. So this idea remains in spite of the cosmological worldview. But it remains really on a more abstract level, and in a sense, in most of the cases, devoid by its mathematical meaning. So I didn't say any word until now about geometry. And I think geometry has the same experience, the same destiny as arithmetics and music, so moving toward practical applications, in spite of the fact that they are all still quadrivium, because this idea remained. And remain the classificatory idea used for knowledge until the 17th century. So geometry was associated to the classes in Euclid elements, mostly for 3 books, sometimes up to the 6th book, but never over the 6th book, which already tells something about which kind of geometry they were learning. Because if you look, for instance, in the Bottega degli Artisti, so the artist workshops in the 40th and 50th century in Florence, that they had the evening classes in geometry, they were learning exactly the same, either 3 or first 6 books of the Euclid's elements. So it's more, for practice it works, everything else is not really needed. Then we have another book which is very actually unknown nowadays, even by historians. I couldn't find anyone who's been working on this work, but it was used a lot in the 30th century in the universities and in the 40s. Is Euclid the Quantitativus Datis, and then the Triangulis of Jordanus the Mentor, which is a genuine medieval geometrical book. But geometry is actually one of those disciplines that experienced the greatest expansion already in the medieval period, but not only toward practice. There are also exceptions. So, first of all, we have the association of geometry with statics. So students were not only learning the Triangulis of Jordanus the Mentor, but they sometimes at least were learning also the Ponderius, so static, which obviously makes it easier then if you want to move toward more practical aspects, because statics relates very clearly to machines and to the motion of the way of working with machines. Then we have the genuine, interesting medieval phenomenon, which is the emergence of something that from the medieval period is called a discipline in itself, but it came out of the class of geometry, and this is optics. And optics, thanks to the work of Grosseteste, Roger Bacon, Victor, and Peckham, these are the great makers of the medieval optics, and they recuperate, they retrieve ancient books, Optics and Catoptrics by Euclid, the methodology, then alchemy, and then later on, process dynamic other thing. So this is a huge expansion in the medieval period. And I would like to point to the fact that some of these people, Bacon, Peckerman, and Grosseteste, were Franciscans. You will see at the end why I want to put your attention to this aspect. And apart from this great expansion in this direction, optics is obviously also a theoretical discipline, it's not a practical one. We clearly have more practical aspects, geometry and architecture. As Wolfgang Lefebvre in Berlin, a colleague of mine has shown in the last 15 years, I would say, there was associated to the constructions, especially of the medieval cathedrals, there was the emergence of a new geometry, which was basically, in the fundamentals, unrelated to the elements of Euclid. So it was more practical oriented, understanding of the postulates, but there are theorems and way of proceeding, and there are way of constructing, so to speak, that are not directly related to the elements of Euclid. So that you have to study one in order to understand the others, basically. So there is a new geometry coming up, and this obviously had a successful path, as we know. It's enough to see the cathedrals nowadays, and everything that has been made in the period in Europe. And then we have what I mentioned a little bit before, so the connection between math and mechanics. So we have already seen that already in the 13th century, students, at least in Paris, and some universities started learning the ponderibus at the university, statics, principle of the lever. Then we have the 16th century with the retrieval of the Aristotelian mechanical problems with a dynamic approach to the principle of the lever. And then we have the emergence of the first modern theoretical mechanics, which is based on the principle of the lever, obviously. And it is the great conjunction between what was called machine building, the practice of machine building, and geometry, and mechanics with Aristotle. So in this way we have the formation of the theoretical discipline that was obviously relevant, especially in the 16th century, in a century of booming architecture, booming machine building everywhere. So where this interest was there was an interest, and not by chance we have the emergence of a new discipline in this period like this. So, and here in the words of Agostino Ramelli, who is an author, is not even a theoretical author, he's an author of a theater, one of the famous theater of machines, that even call it the mathematical art. You know, this is a mathematical art. Mechanics is a mathematical art. So this was at the end of the 16th century the perception of mathematics, one of the strongest perception of mathematics in the sense of geometry, in this case, in Europe. It was related to this machine. So you see here we have a great expansion, and still the surviving idea of the quadrivium, but we are into fields, we moved into fields that are really unrelated to the original fields of the quadrivium. So now we move to astronomy. Astronomy, at the very beginning, is very articulated already. The Boethius Astronomia disappeared also for the 13th century students. And so it had to be replaced. We have here the ingestion of a huge amount of works also from the Arabic science. So Alfargani elements, the Almagestum Abbreviatum, Grosseteste sphere, Sacrocosca sphere, and then we have the tables, the Alphonsine and Toledan and Alphonsine tables. And then so also slowly the reception of what we could call now Alfargani's Theorica. Theorica was treatises to learn how to calculate the position of the planets. So it's something that fills the gap between learning the sphere, that gives you the idea of the machina mundi and how everything moves in which direction, but you don't know how fast or how slow. And then you have the tables to calculate that. But in order to learn how to calculate this, you need the Theorica. So the Theorica developed for this reason, in this direction. So basically, one of the functions of the original functions of geometry was obviously to be there in order to give the students the possibility to learn astronomy. Especially, imagine you read the Almagest. I don't know if you have ever opened the Almagest of Ptolemy. If you don't know anything about geometry, you would never understand anything in this book. So in this sense, geometry was also necessary to astronomy. But how many people were really reading the Almagest and studying the Almagest? Actually, really only a few. So astronomy and geometry was there for astronomy, but rather, let's say, in order to understand the use of the quadrants and other aspects that weren't being taught at the university in the frame of the class of astronomy. And also the Theorica, whether all the students really learned and went through the Theorica and learned how to calculate the position of the planets, I'm not so sure. I think nobody knows at the moment. For sure many, but for sure way less than those who read only the sphere of course, deste or Saturday or the. So astronomy, however, at the beginning was there in order to have a mathematical grasping of the cosmos, bringing it together with music. But soon, also astronomy changed a little bit its nature and function. And it changed toward an application of astronomy. And the major point, the major kind of application of astronomy was related to astrology. Astrology is the real knowledge motor of the 40th and 15th century. Astrology was then applied to medicine, and we will see it in a second. So everything was there in order to study or in order to be able to make astrological calculations. Or, I mean, in many cases. Then cosmography and nautical astronomy we will see in a second. Centra will say only a few words, as here I think there are the super experts of the world about this subject, so I won't dare say too much and about these last subjects, but I will just mention them in a second. Here, just to give you an example, this is a manuscript of a student in the 13th century in Paris, end of the 13th century, so you see the kind of works that they are making, so you see Confucius, I come in a second on this kind of works, but apart from the calendrical works, you see that it's all about astronomy, math, tables, and cosmological and astronomical issues. If you move about 100 years farther, you see another manuscript collection of another student. You see that things have already changed. Still have astronomy and as before, a little bit less, although this might depend on the selection that I made. But what is typical for this period, starting from the 14th century, to find, I checked all of the manuscripts in Paris, the Mazarin that contain the Sphere of Sacrobosco, so there are about 40 books, 40 boxes. And you will see that the presence of astrological subjects become more and more dominant, or astrological medical subjects. And there are almost no there at all in the 13th century. So there is this change. And even when you see here, the last work is the Lapidaria. The Lapidaria is obviously a medical work, a medical and astrological work in this period. It's not geophysics. No? So, and astrological medicine became, I don't know how much you know about all this, probably you know a lot. So you see this is a typical Voltaire for physicians in order to calculate in retrograde position or so ex post backwards in time the position of the planets when a certain sickness emerged, because the theory of the days of crisis of Galen became again very, very important through the Arabic transmission. And we have also the emergence of new genres over time in this sense. So like the folded calendar that you would carry on this side with, and you can see with the zodiac man, or you can calculate with some kind of theoretical or that, also this kind of thing. So this is the kind of mathematical astronomy more and more needed, and it is absolutely perfectly integrated with medical astrology. And another new genre in the so-called, that was born in the so-called fortress of astrology, which is the South Germany, and it was the core, let's say, the triangle between Bohemia, Prague, Nuremberg, and Leipzig. where you have the emergence of these almanacs, the idea of the almanacs, so the one needed to in principle put on the wall for every year, so something could go everywhere to everyone, or the practica, which were a little bit more sophisticated with the booklets, and sometimes in Latin, very often in Latin also, not only in local tongues. So you see that this all relates in the perception of the time to astronomy. This is the astronomy, and the astronomy is needed for these reasons, which were completely absent in the original version of the quadrivium. Then cosmography, clearly we have the emergence of a different geography from the medieval geography that you see an example here, which is there with a lot of important subjects, historical, economic, confessional, whatever you want, or geophysical, but there is no magic. There is not a representation of the world that can be used for other purposes. So the retrieval of the magic through the Ptolemy's cosmography is obviously there out of a problem-solving approaching because of the journeys of exploration, because of the increasing mobility everywhere outside of the known places. And this metric could only be achieved by a projection of the already existing metric from outside to inside. So after Ptolemy's, and when Ptolemy's turned out to be insufficient, then the metric was developed in concomitance in relation to the metric that already existed for the celestial sphere. So again, astronomy and cosmology. And here is a beautiful page that shows this connection. And then obviously nautical astronomy is a big chapter, you know it perfectly, but this is also something that was clearly not there originally in the quadrivium and in the conception of astronomy as part of the quadrivium. But as you perfectly know, became an extremely relevant subject, and in my project of the sphere I can see how much nautical astronomy becomes more and more present in the treatises, together with the spheres of philosophy. So they were completely unrelated at a certain point, became a very normal connection. There was no need to justification for that. It was perceived like this. So now we come to the end, but not the end with the E, but we have to suffer a little longer. So in my opinion, there is even more than all this, even more than these changes that are already there from the 13th century and become more and more prominent over the centuries. But there is already something else there in the 13th century. This is really the first time I'm speaking about this, and I haven't published anything, and I don't know, if you now throw me bananas and so on, I won't publish, but maybe yes, if you accept this. So let's start with this. Please read this beautiful sentence with me. It's so close, so small, because we have a little problem, we have a technical problem. I can't read it because it's too small for me, but you can read it, no? Yeah. Okay, so it's a very nice, please read it, I'll give you a second. Okay, so this beautiful citation from a great French historian of the first part of the 20th century, really a great one. If you have to read something from him, do it, because it's a great historian. So as you see, the 13th century had a problem. It was not an easy problem. Literally, we would live now in a place like this, so how would it come? No? Everything would go wrong, we would probably arrive late to the lecture. From the lady who knows, Protestants, and everything would be completely wrong. So, and this obviously was a problem also in the period. I have already mentioned a few times, we have the emergence of a new mobility. Obviously, it doesn't consider everyone in the society, or not the mass students that we know now, or that we knew a few years ago. But still, this became problematic. And this became problematic especially because there was another goal, another mission going on before, that started even earlier than this period. And this mission was related with the emergence of the new feudalism and the new clerics and the clergy and the new order after the dissolution of the Carolingian Empire first, and then those 1.5 centuries of chaos in Europe, and then we have the emergence of a new system. I don't know if you, I discovered only a few weeks ago, I didn't know, that it is only from the 12th century on that the church had the idea that everyone goes to Mass on Sunday. Before that, there was no rule about the Sunday Mass. You know? So I didn't know that. This is something that goes together with all this that I'm about to tell to you. So starting from the 12th century, the church decided to have a political mission in Europe, a unifying mission in Europe. Don't enter into the subject, of course, but one of the instruments used to make clear this identity and this unifying process was to try to synchronize the people. Synchronizing the people means everyone was consigned to the church and not whatever they did. It also goes that honoring the saints had to be possibly as much as possible the same saints on the same day. That was not the case at all. This starts in the 12th century with the first 8 saints. And then it's really, literally, a battle between the central and the local powers in Europe until the 16th century in order to get a calendar that roughly resembles the liturgic calendar that we have nowadays, at least in the Catholic Church. Concerning the structure, then obviously the saints might have changed, I don't know. Very important for this process was the Decretalium, the Liber Extra of the 13th century, which is basically, it was a way they resettled all the juridical aspects of the church completely, since always, in the time of a few years, in this so-called Liber Extra. And this gave the fundamentals to proceed in any political directions that happened after that. And one of that was the liturgic calendar. So we have, okay, there are many events in this direction. The formation of the Razionale Divinorum Officiorum, which is a work that had even more edition of the Stele of Sacrobosco. So how to make the Mass and when to honor which saints. And so this story goes on until the 16th century, and as we know, it actually ends with the calendar reform in 1582, which was a way to systematize the calendar, not really because of astronomy and so, but because the major reason was this idea of having an harmonized society concerning the liturgical aspects. But there was a problem. And the problem is that the most important of all liturgical feasts is Easter. And Easter had to be determined, the date of Easter in advance, because all the other feasts are dependent on Easter. And this obviously dependent on something else than just political power. It depended on the understanding of the solar calendars, because the determination of Easter depends on both of them. So, and here is where we have some problems. But these problems were known since always. It was not something that in the 13th century, oh, we don't know what's going on. They knew it perfectly. If you read Bede, the divine Bede, the guy who systematized the local anglical knowledge of the medieval period in the 8th century, it's a beautiful work in the translation of Faith Wallace. If you haven't done, have a look at this great work. Bede already tells you that there are all these mistakes, cumulative mistakes in the 8th, I don't remember now, the century 8, and yes, in the 8th and 11th and in the 19th years, because they had the 19-year cycles to calculate the Easter date. So they were all known, but they were all accepted, because as a matter of fact, the calendar and also the liturgic calendar is something that brings together astronomy. That was not the most important aspect, together with the habits, the uses, politics, theology, a little bit, exegetical works, and just acceptance. You know, if the society is peaceful, you got it, even if you make a mistake with the Easter day. So this is the point. But in the moment you are trying to synchronize the liturgical calendar for everyone, then obviously the mistake becomes increasingly less and less tolerated. So here is a typical Easter day table, if you haven't see this anymore. So, and in the 13th century, you start seeing the echoes of this lack of tolerance against for these mistakes. So Bede was easygoing. In the 13th century, it was a little bit less easygoing. So here's Sacrobosco teaching the students that actually the church doesn't really need astronomy, but yes, it needs astronomy, because we should be able to calculate, to understand better the motions of the planets and the machina mundi, in order to calculate better these things. So the church giving inputs to the sciences for one practical reason. As a matter of fact, then Sacrobosco is a nice proemium, but then, as a matter of fact, in practice, we still have the Volver with the use of mistakes that we didn't change. The Computus Ecclesiasticus of Sacrobosco was very well accepted and used. So now consider this, that we have way more Computus Ecclesiasticus than Spiro Sacrobosco. So this means that everyone actually was learning this stuff at that time. But you don't find any statute of continental universities that puts the Computus as a class. We don't know. We don't know anything. We know that a lot of these manuscripts for students are everywhere. And we don't know how it was implemented in the class, in the statutes of the university. We don't know which zone of students were there. Were the clergies? We know some of them were going for, there was a habit in many universities to go for 1 year just. So without expecting to finish it, to get the first degree. So were they the clergy to learn these aspects and then go back to their places of origins in order to be able to calculate the calendar properly? So my suspect is that as in the 13th century it was impossible to have one central astronomy authorship giving the Easter date for the next 19 years and sending it to every locality. This is something we would think we would do now. So there is somebody as authority and we tell everyone. How do you tell everyone in the 13th century? So in the 13th century, if your will is to synchronize everyone, then you want everyone to get the same knowledge, to make the same calculations, even with the same mistakes. It doesn't matter. So and if you think of this in these terms, then you understand why I pointed to the Franciscans. Because we have a lot of these manuscripts in the universities. We know that universities were connected to, let's say, Franciscans and Dominicans or Dominican friars in general. And we know that the Dominican friars were going everywhere. Not only the Franciscans, but my suspect that the Franciscans were the most active in distributing also this kind of knowledge. We don't know, we know a lot about the Franciscans and the Dominicans and what they did and so far and so on, but we don't know so much about what they did in terms of science and teaching of science, unfortunately. And this is something that has to be done. That's why I always said, should I have it or not? Because I don't know. I couldn't find anything about this, but this is my suspect. The only place where you can find the Computus in the statute is in the Oxford School of the Franciscans, and they were learning the Computus of Grosseteste. But the rector of the school was Grosseteste himself, so okay, so it's not really representative, let's say. But at least they were Franciscans. So this is the point. And then look at this manuscript that I found 1 year ago. This is a 13th century copy of the works of Sacrobosco. Sacrobosco wrote the Sphere, the Computus, an algorithm, and the quadrant. These 4 works. This is a copy of these works all together made in the 13th century. And then there is a last page added to this in 1371. And this last page contains the permission of the king and the pope, or both of them, to send this copy to the convent of Troyes, Dominican convent of Troyes, which was recently founded in those years. Because the convent of Troyes had asked the king to have copies of the books necessary in order to learn how to calculate the history, the Computus Ecclesiasticus. So, and everything else is probably there. You need the quadrant, you need the algorithms probably, I'm not so totally sure, but you need the sphere, for sure. And obviously the Computus. So this is the way that works. So if you think now of the computus and this, it has a connection to astronomy, obviously. It's not as strong as you might suppose at the beginning. So basically you do maybe one observation a year, and you learn how to transfer from one table to the next in some workflow, mathematical, arithmetical, practical workflows. And then you have your vowels and this kind of things. But there is a connection to astronomy. But especially if you think of this movement, if it is true what I'm saying, it has to be demonstrated, then it means that we have an incredible spread of mathematical knowledge and practical mathematical culture all over Europe. While the Franciscans were making Europe, they were making it on the basis of math. And math, however, there was no more the math of the quadrivium or with the mission of the quadrivium. It was related to this. But this was already in the 13th century. So in the 13th century, when you find the Corpus Astronomicum, you find always all the astronomical works with a lot of calendar works. And only after this period you find astrology, medicine, and so forth and so on. So the priority already in the 13th century seems to be the calendar and not really the mission of the Musica Mundana and the understanding. So it's still, let's say, the church and finding the creator, but it has a more, let's say, practical approach. So this is really the end. And the end is just a little summary. And of what I have said, we are from the with the number theory to the merchant's arithmetics, Pythagorean monochord and this cosmological application to practical music and bit theory, from the geometry of the cosmos to practical mechanics. The difference is less precise than in the other cases because also the cosmos and geometry is dynamics. It's not just a static. But then we have in the frame of astronomy from cosmological harmony to applied mathematical astronomy, astrology, medicine, and especially calendar. And so all in all, why this integration? Because I think that basically what we have here is a quadrivium that over the centuries lost its mission, its meaning, and remained more and more like a container to say, okay, these are the mathematical disciplines, this is math, this is geometry, so far and so on. But what especially was missing then is that the mathematical disciplines were no more necessarily connected to each other. They don't need each other from a logical point of view, all of them as in the same way, as it was before. So this is the kind of disintegration that I'm speaking about. It's this harmony at the level of mutual interdependencies among disciplines that is no more there. So quadrivium becomes an empty container, and in fact, as an empty container, it disappeared without great knots. People just stopped speaking about this, and they continue making everything that was already in there. So there was no revolution because the people stopped speaking about it. It just disappeared. It's more a process of oblivion and disintegration. Thank you.